exact roots. So if you say square roots of 9, we have 3, then we say 9 is a perfect square. This is not sort. But if we say square root of 32, we can't have an exact value for this, and we call this sort. So that is what is meant by sort. In sort, we have rules for sorts. And the first rule, rules for sorts. So the first rule is rule number 1, which says that mn, root of mn can be written as root m times root n. Then we also have the second one, which says that root m divided by n can be written as root m over root n. It should be noted that root m plus n cannot be equal to root m plus root n. Root m minus n also cannot be equal to root m minus root n. We have to note this. So these two rules are very important in solving problems relating to sort. Now, example 1, which is shown in figure 1.1a. And figure 1.1a, this is figure 1.1a on the board. The A part will have root of 75, and the B part will have 80. So here, solution to this, we have the A part, which is 75. And we know vividly that product of 75, whose multiplication will be a perfect square, will definitely be 3 times 25. If 3 times 25, that will give us 75. And one of these automatically will definitely be a perfect square, and that is 25. So the logic to answer questions under this, or question of this nature, is to find the product of two numbers. Which one of them must be a perfect square? This is a perfect square, this is not a perfect square. So we can say root of 75 is simply square root of 3 times 25. And here we know that by the first rule of sort, we know that we can split this to root 3 times root 25. And root 25 is simply 5. So root 3 times 5, and that will definitely give us 5 root 3. So therefore, square root of 75 will now be 5 root 3. Then the second case, which is 80, root of 80. So I said the concept which makes it easier here is to look for two numbers whose product, one of them, will definitely give us a perfect square. And we have 16 times 5. 16 times 5, 80 is equal to 16 times 5. So automatically we can say 16 times 5, and which you can break as 16, square root of 16 times square root of 5, or root of 16 over root of 5. So root of 16 will give us 4 times root of 5. Then eventually we have 4 root 5. So automatically, therefore, root of 80 will definitely be 4 root 5. So that is the answer to example 1. We can still move further to talk about addition and subtracting similar sorts. And example 2 is here on the board to justify the claim. So here we have root of 50 minus root of 18 plus root of 32. Here we have a subtraction, we have addition in the system, which are also occurring simultaneously. So here we have root 50 minus root 18 plus root 32. So if you want to simplify this, is example 2. This is example 2. Here, if you want to simplify, you can say 2 times 25 will give us 50 minus 2 times 9 will give us 18 plus 2 times 16 will give us 32. Root of 25 is what? 5. So we can write this one as 5 root 2 minus root of 9 is what? 3. We can write this one as 3 root 2 plus root of 16 is what? 4. 4 root 2. So 5 root 2 minus 3 root 2, that gives us 2 root 2. 2 root 2 plus 4 root 2 root 2 plus 4 root 2, and that will give us 6 root 2. So the answer to that question will definitely be 6 root 2. Now, we talk about the next concept is the rationalizing the denominator or rationalization. So if you have to rationalize the denominator, it is simply done rationalizing. But this time we pay attention to the denominator. So if you have a fraction such as a over root b, and our interest here is to rationalize. So we'll try, since it is the base that has sort, so we are meant to rationalize the base. So if we have to rationalize the base of this, so automatically what we do is that we are going to look for a fraction of this base. The fraction of the base is root b over root b. So we use this to multiply what we have. So that is what is known as the concept of rationalization. And so if you have to do that here, we have a over root b times root b over root b. So this a times root b will give us a root b over root b times b. So automatically this one will give us a root b over root b squared. And a root b squared is b. So automatically this is what we have. So now we have succeeded in rationalizing this, and we have this as our result. So that is the concept of rationalizing. Here, example 3 is shown in figure 1.1c. Look at the figure 1.1c on the board. Figure 1.1c, which is example 3, is telling us that if root 3 is 1.732, find the value of 2 root 3 and correct to 3 significant figure. So if you are to attend to this example 3, which we are given 2 root 3. So here, we can't use any other concept rather than the concept of rationalization. And since we have seen from the question that it is the denominator that has a sort, so the first thing we have to do is to look for the fraction of that denominator and use it to multiply it. And that is the concept of that. So which implies that 2 root 3 times root 3 over root 3. So here, 2 times root 3, that gives us 2 root 3. And this one will give us root 3 times 3. And that will be 2 root 3 over root 9. Then that will be 2 root 3 over 3. So we have succeeded in rationalizing that expression. So here, since we have rationalized the expression, this question still asks us to give, the question gave us a value for root 3 and asks us to express in 3 significant figures. So what we are meant to do is to use the value that is given to us. The root 3 has been given to us in the question to the root 3 has been given to us in the question to be 1.732. So here we have 2 root 3 over 3. So we are to evaluate this. 2 times what is the root of 3, and it has been given to be 1.732 divided by 3. So what we are meant to do here is we multiply 2 times 1.732, then we divide by 3. So we are having 1.515467. That's the value that we have got. And here we are meant to correct this. We are meant to correct this. We are meant to to take this to three significant figures. This is the first significant figure, this is the second significant figure, and this is the third significant figure. So the number that you have after this is 4. So automatically it will be 1.15 to 3 significant figures. So our answer is this. Is our answer to 3 significant figures. Example 4. But before the example 4, we are meant to talk about the conjugate sorts. Given the sort expression a plus root b, then a minus root b is called its conjugate. The product of a sort and its conjugate is not a sort. So let's prove that. So the first thing we have to do here is we are made to understand that a plus root b, okay, the conjugate of this, conjugate will definitely be a minus root b. So this is the conjugate of this. So automatically, but we are also made to realize that when a sort and its conjugate are multiplied, the resulting product is not a sort. So let's prove that. Let's confirm whether it is true. A plus root b, a minus root b. So we can say a into a minus root b